Hi. The purpose of our invention is essentially to make an electric train. We will be making a train with a battery and magnets, and it will move through a copper coil. As you can see here in this video from YouTube, this is basically the train we're attempting to make. As for materials, you'll be needing a 10-meter coil of copper wire or even longer, and you just simply coil them up on a whiteboard marker. Make sure to coil up real tight. After you're done with all that, you'll end up with a long spring, basically. You also need some small magnets and a battery. And now you have to take apart the magnet and make sure they repel each other. And you just stick it on to both ends of the battery. Basically, you have something like this. Notice the magnets must repel or the train will not move. Now it's time to build it. One precaution is to please wear rubber gloves, as there will be an electric current and some heat on the wire. We kind of realized this precaution after we did the experiment, and we already filmed it, so just please bear with us. And don't repeat what we did. Now with that coil and the train, you simply just shove it in, and the train will move by itself. Let's rewind that up and put it in slow-mo. Whoa. So how does this work? Basically, if we draw this coil of wire out and the train next to it, when the train goes through the coil, the magnets touching the wire would induce a current with the battery. The current created would then create a magnetic field. In this example, the current will move from right to left. A solenoid will be created. As a result, the North Pole will be on the right and the South Pole will be on the left. And the magnetic field lines will be directed in the ways as shown. Now let's look at the train. Why do we need the magnets to repel? The reason can be seen right here in this diagram. Because the magnets are repelling, the south end of the left magnet will repel with the South Pole created by the currents in the coil. The south end of the right magnet would attract with the North Pole created by the current in the coil. Thus, the general direction of the train will be to move towards the right.
Thumbs up, thumbs up.
Here are some friendly advices to those who want to replicate the electric train. The first time we did this experiment, we chose a very thin coil, and that kind of resulted in the train not moving, and so that kind of failed.
Hello darkness, my old friend.
The reason it did not move was because the thinner the wire, it will mean a higher resistance, and the higher the resistance will mean less of a current, and the less of a current will mean less of a magnetic field. And so we advise you to use a thicker wire, just like we did in our successful trial. And just please use rubber gloves at all times when doing this electric train. Special thanks to these sources that helped our understanding of the topic. Thank you for watching, and like and subscribe.